My name is Bill Bowen. I'm a project management instructor here in Ottawa, Canada. In this video, I'm going to give my thoughts on earned value management. This is a subject that can initially appear overwhelming, but one that hopefully we can simplify. So let's get started. Earned value is a structured approach for determining the progress and status of a project based on its performance. It builds upon the work that was done as part of the project's definition and planning phase. In particular, it utilizes the project's WBS, budget, schedule, and work performed to date to provide insight into the project's progress. In this video, I'll examine the concepts behind earned value, introduce each individual formula, and then give an example of how the whole system works. I'll also provide strategies for how to estimate progress on a project when it cannot be determined directly. Let's demonstrate the need for earned value by examining a simple project. Our project only has 6 activities, but things have not gone as originally planned. The blue bars show the planned duration for each activity, while the green bars shows work completed. Some activities are behind schedule, such as Activity 4. Other activities are on schedule, such as Activity 2. And some activities are ahead of schedule, such as Activity 3. Clearly, things have not gone according to plan, but the big question is whether or not the overall project is on schedule, ahead of schedule, or behind schedule. While you might be able to figure out the project's overall status for a simple project such as this one, it can become challenging for more complex and larger projects. Earned value management provides a structured approach for evaluating the status of a project, even if the project is not going according to plan. I fully understand that when you first see all the earned value formulas in the PMBOK guide, they can appear overwhelming. But most of the formulas are quite intuitive once you get to know them. Let's look at each one and see how they are used. Earned value formulas come in 3 distinct categories. Variance analysis formulas identify the difference between what was planned and what is actually happening on the project. They identify the differences in planned cost versus actual cost and planned duration versus actual duration. The next category is trend analysis formulas. These formulas help us understand how progress is proceeding on the project. They identify if the progress is proceeding faster or slower than originally planned. The third category are our forecasting formulas. These formulas allow us to project cost estimates for the project that are based on the project's performance to date. This all sounds good, but how does it work? The key concept behind earned value is that each project activity has a value defined within the project budget. Completing activities earn the project this value. As the project progresses, we can compare how much value the project has earned against what the project was expected to earn. In this illustration, we see the high-level concept of earned value. As the activities in the Gantt chart are completed, the project earns value. This accumulated value is shown in the lower graph. The project is considered to be completed once the accumulated value equals the project's original total value. That's the high-level conceptual overview. Now let's get down into the details. There are 3 basic elements that need to be known to make earned value work. They are the planned value for each activity, the actual cost accumulated for each activity, and how much value each activity has earned for the project. Planned value represents how much value each activity is expected to earn by a certain point in the project. You can usually determine an activity's planned value by examining its original budget along with the project's original schedule. Actual cost refers to how much material and labor expenses have occurred for an activity at a particular point in time on the project. We can update our table by adding a new column that shows how much has been spent on each activity so far. How do you determine these actual costs? In a work environment, you would have to look at invoices, purchase orders, timesheets, or financial tracking programs to find actual costs. But in an academic environment, this information is usually just provided to you or provided in the form of a formula that would allow you to calculate the actual cost. The next term we'll look at is earned value. The term earned value refers to how much value an activity has produced for the project. If an activity is halfway complete, you can think of it as having earned half of its value. Similarly, once an activity has been completed, then you can consider it to have earned all of its value. On some projects, it is possible to determine exactly how much value an activity has earned for the project. If you can count an activity's output or if you can determine an activity's progress through some kind of analysis, then you can quantifiably determine how much value that activity has earned for the project. For example, this approach would work well on an assembly line where the output can be easily measured. For these type of projects, it is possible to determine exactly how much value each activity has earned for the project. However, this approach does not work on all projects. At the end of this video, I'll present ways to estimate how much value each activity has added when it cannot be determined directly. That was the basic elements of earned value. Now let's put what we've learned about planned value, actual cost, and earned value to work. Let's start by breaking down all these earned value formulas to see how each of them work and what they can do for us. The first set of formulas are the variation formulas. They will tell us how far off the original plan our current project's progress is. Let's begin with the cost variance. This formula examines the difference between the value that's been earned on the project and what we have spent to achieve that value. This is done by subtracting the activity's actual cost from its earned value. Ideally, the cost variance should be 0. This means that we are on budget with this activity. A positive cost variance is good, as it indicates that the activity is actually under budget. A negative cost variance indicates that the activity is over budget. A similar variance formula exists for schedule variance. The schedule variance in an activity is the difference between an activity's earned value and its planned value. If an activity has a negative schedule variance, then that activity is behind schedule. A positive schedule variance means that the progress for that activity is ahead of schedule. This table provides a guide to interpreting positive and negative cost variances and schedule variances. As you can see, in general, positive numbers are good, negative numbers are not so good. Now let's move on to trend analysis formulas. These formulas can be used to determine if the project's overall progress is going according to plan or not. Our first performance formula is our schedule performance index. For this formula, we divide the value earned by the value of what we had planned to earn at that point in the project. If we get a ratio that is greater than 1, then our overall progress is ahead of schedule. Correspondingly, if our schedule performance index is less than 1, this indicates that our performance is less than what we had originally planned. We have a similar formula for assessing the cost performance index for the project. In this formula, we compare how much value the project has earned against how much cost it took to achieve that value. The formula for the cost performance index is earned value divided by actual cost. Here's another helpful table for interpreting schedule and cost performance index values. As you can see, ratios that are greater than 1 mean things are going well, while ratios of less than 1 means that the progress is not going as well as planned. Now let's move on to looking at our forecasting formulas. Forecasting allows us to update our estimates for the project's overall cost based on its progress to date. There are two ways to project the project's estimated cost at completion based on the work to date. We can assume that the progress trend that we have seen so far in the project will continue, or we can assume that the rest of the project will go according to plan. Let's look at how we would update our project's cost based on both of these assumptions. First, we will assume that progress to date is an indicator of progress to come. Here we will take our project's overall budget, which we will call the estimated at completion, or BAC, and divide it by our cost performance index, which we calculated earlier. This gives us an updated estimated project cost based on the current progress trends. Next, we will look at how to calculate an updated project cost under the assumption that past performance will not be reflected going forward and that the rest of the project will go according to plan. In this formula, we will add the actual cost of the money spent on the project so far to the project's total budget. We will then subtract how much value the project has earned to date. The result is an updated estimate of the project's anticipated total cost. We can also calculate the variance that now exists between our original project cost and our updated project cost. This is done simply by subtracting the original budgeted cost for our project from our updated cost estimate. We can also calculate how much we would have to improve our efficiency to get the project done on budget. By dividing the remaining work by the remaining budget, we can calculate how much we would need to improve our efficiency to stay on track to complete the project within its original budget. For this project, we would need to increase our efficiency by 150% to complete this project within its original budget. That was a lot of theory to take in all at once. Let's now see what we can learn from earned value management from a more practical example. Let's look at a renovation project. Supposing that we have a project to renovate an apartment with 6 main areas. For this project, we'll assume that each of these areas will be its own separate activity on our project. As part of the planning process for our project, we could do an inspection of each room and estimate how much it would cost to complete each room's renovation. This amount could be used to determine both the project's overall budget and the budget for each individual activity. We could summarize the cost of each activity within a table such as this one. Next, we could look at our available resources and figure out when each activity could be scheduled. This information will allow us to produce an overall schedule for the project. Now, suppose at the end of day 5, we want to determine how much value the project should have earned. This information will represent the project's planned value for day 5. If we assume that value is earned linearly throughout an activity's duration, then we can use each activity's budgeted value and its schedule to determine what its planned value should be at any point on the project. Clearly, activities that have been completed by day 5 and any activities that are underway on day 5 should earn whatever portion of their values would have been completed by that point in time on the project. As you can see, I filled in the rest of our table using the planned values for each activities. Now we can determine the actual cost for each activity. In most earned value problems, the actual cost will simply be given to you as part of the problem. On a real project, you will have to find out each activity's actual cost by reviewing the project information such as invoices, purchase orders, or sales receipts. For our project, I simply made up actual cost numbers and filled them into our table. Now let's move on to determining each activity's earned value. On our renovation project, we might be able to assess progress by simply doing a room-by-room inspection to see what has been completed. To make things interesting, I'm going to assume that our project has not gone according to our original plan. For example, the renovation of bedroom 1 was supposed to have been completed by day 5, but so far it is only 75% completed. By multiplying the activity's percentage complete by its original budgeted value, we can determine the activity's earned value. I have repeated this process for each activity and updated our table accordingly. We can now move on to calculating what variances exist on our project. We can start by calculating cost variance. Cost variance is simply the earned value for an activity minus its actual cost. I've done an example for the table. Using this same formula and approach, the cost variance for the other activities can also be determined. For use later on, I've also determined the total cost variance for the project. Schedule variance is similar in concept to cost variance, but the formula uses planned value instead of the actual cost. I have applied schedule variance formula to each activity and updated our table accordingly. For use later on in this video, I've also summed up the totals for each column. If we consult our variance interpretation table that was introduced earlier in the video, we can see that our project is under budget but behind schedule. Along with determining the cost and schedule variances for individual activities, we can also determine the performance indices for the project as a whole. While cost and schedule performance indexes can be calculated for individual activities, it is often more informative to calculate them for the project as a whole. To calculate the cost performance index for the project as a whole, simply divide the project's total earned value by its total actual cost. Similarly, we can find the project's schedule performance index. The project's schedule performance index can be found by dividing the project's total earned value by its total planned value. Both our schedule performance index and our cost performance index will be used later in this video to support other earned value formulas. However, for now, we can consult our performance index interpretation table to see that our performance indices reinforce what our variance indicators showed, that our project is under budget but behind schedule. The cost performance index can be used in providing updated cost estimates for completing the project. If you recall, there are two ways to project a cost completion estimate. One way is to assume that progress to date will continue as it has for the rest of the project. The other way is to assume that the rest of the project will go according to the original plan. Let's see how to get an updated cost estimate for the project under both of these assumptions. First, let's assume that the progress to date is an indicator of the progress to come. To get an updated estimate for the project's overall cost under this assumption, we would divide the original project's budget, or budget at completion, by our cost performance index. This provides an updated cost at completion value estimate that is based on the project's progress to date. Alternatively, we could assume that the rest of the project will go according to the original plan. To calculate an estimate for the project's overall cost under this assumption, we would add the project's actual cost to date to the project's original budgeted at completion value. We would then subtract the value that the project has earned so far. This would give us a different updated cost estimate that is based on this different assumption. As you can see, we end up with two different estimates to complete the project. They are based on two different assumptions for how progress for the rest of the project will occur. Let's now look at the variation between the original project budget and these updated estimates. Variation at completion is calculated by subtracting the updated estimate from the project's original budget at completion value. This gives us the difference between what we're now estimating and what we were originally estimating. We can also calculate how much money it will now take to complete the project based on these updated estimates. How much money it will take to complete the project is the difference between our estimated completion cost and the actual cost encountered to date. I have shown these calculations for both of our updated estimates at completion costs. And finally, earned value provides a to complete performance index for the project as a whole. By dividing the work remaining by the remaining budget, you get a ratio that shows the overall project performance. Hopefully our practical example has demystified some of the formulas behind earned value and shown that these formulas can provide useful information that can be used in project status reports or briefings. As you can see, there's quite a bit to earned value, and it can take a bit of practice before you can use it effectively on a project. But the information that it provides is very valuable. You may have noticed that earned value depends on you being able to quantifiably assess the progress for each activity in order to determine how much value it has produced. But how do you determine value for each activity whose progress cannot be easily measured? For these type of activities, earned value can use estimating methods that, while less accurate, do take the guesswork out of determining an activity's progress. When you cannot determine how much value an activity has earned through direct observation or analysis, structured rules, such as the 50-50 rule, exist to remove the guesswork and provide a framework for estimating value earned on an activity. With the 50-50 approach to estimating progress, 50% of the activity's value is awarded once the task has been started, and the remaining 50% is earned when the activity is completed. This results in an estimating progress approach that, while less accurate, can be consistently applied and removes the guesswork. Lots of other rule-based approaches also exist. For example, the 0-100 rule is an approach where an activity earns no value until the activity has been completed. This approach ensures that only value truly earned is awarded to the project. The downside is that progress can be underreported as no value is awarded to the project for any and all ongoing efforts. Other rules include the 25-75 rule or the 10-90 rule. What all these rules have in common is they try to provide a very structured and consistent approach to estimating progress and value earned on a project. None of these rules rely on guessing how much value a particular activity has earned. Instead, they are all rule-based. When you are unable to directly determine the value that each activity adds to the project, you need to select the rule-based estimating approach that best suits the project that you're on. In this table, I have used the 50-50 rule to estimate the earned value for the activities in our previous renovation project. As you can see, for the project as a whole, the 50-50 rule gives an overall earned value result that is close to what we had earlier. Keep in mind that these rule-based approaches are only estimates. They will not be as accurate as actually measuring progress. But they can be used when direct measurement of progress is not possible or practical. Earned value management has a number of limitations, and it is a skill that you become better at with practice. For earned value to be effective, the project has to be set up during the planning phase to support earned value. It can be very frustrating to use the earned value system on a project that was not set up to support it. That wraps up my thoughts on earned value. I hope that this video was useful in explaining the earned value concepts. If you're a student of mine, I look forward to providing you feedback on your assignments, and if not, I hope that you found this video beneficial.